Our original launch time was 6:33 Kourou time. That's 9:33 Universal time. And you can see there.
Suite au retour vers des conditions météo, le nouvel H0 visé est 22h04:00 TU. Je répète, le nouvel H0 visé est 22h04 minutes TU. Le temps décompte démarra à 21h57 minutes 00 TU.
Good. That means that the Range Operations Manager has now announced that everything has gone back to green, and we have a new launch time, which is 10:04 Universal Time, which I believe is 19:04, I think, in Kourou, in French Guiana. So that's good news.
That's great, yes, that's great.
So I'm going to let you go now, Stéphane, and head back to your teams. Thank you very much for joining us. We hope to see you later. Thank you, Stéphane Israel, ladies and gentlemen. And I'm going to introduce us now as well to Damien Gilles, who is an expert who's going to be joining me for the rest of the programme. Damien, thank you very much for joining us. Do take a seat. So, Damien, let's just talk about the status panels, because we could see those status panels on the screen.
Début de la séquence finale lanceur.
Sorry? So, I didn't quite hear him there, but I believe that we've now started the synchronized sequence. So that's good news. The synchronized sequence being the last 7 minutes of the countdown. This is the automated sequence when everything's happening automatically. And you can see the status panels there, Damien, on the left-hand side of the screen.
You have there the status panel, where all the subsystems coming from the launch base, the launch range, the launcher, and the customer give their status towards the mission control center. And it's like a traffic light. If everything is green, it's a go. If it's red, you should stop.
Obviously, and the red status panel means that one of the systems across the base is requesting that the countdown goes on hold. And of course, now our countdown is back on track. So we have a number of different teams in the control center. We have the program managers, who are some of the teams who work closely, aren't they, with the client? What do they do?
Exactly. They are the sole contact between Arianespace and our customers. As you know, the customer is very important for Arianespace. That's why we dedicate people that are the single interface, and they work very closely with the customer. Nearly 3 years for these missions, for both customers. And you can see there on the screen, Marie-Laure Chauffour with the interface for Galaxy 30 and MEV2.
Indeed, working hard there and working closely on her phone, talking to customers, no doubt. Now, we are using, as we said earlier, the heavy lifter of the Ariane family. It's Ariane 5. She's a big, powerful beast, and she's going to lift, hopefully, our satellites into space. What happens after launch?
The booster ignition triggers the liftoff of the launcher. Shortly after, the launcher performs a pitch maneuver in order to get into the required direction. The boosters are separated roughly 2 minutes after liftoff, and then we separate the fairing when it is not needed anymore to protect the spacecraft from the atmosphere. The main stage engine switches off when the launcher detects that the intermediate orbit is to be reached. This event is called injection. The main stage then falls down into the Atlantic Ocean, and the upper stage engine switches on and will carry our satellite up to their injection orbit. During this path, the satellite flies through the atmosphere, which is thin but very fast. It generates aerothermal flux. The upper stage switches off when the final orbit is reached. It marks the beginning of the ballistic phase, where we will separate our customer. First, Galaxy 30, then MEV2. Before releasing BSat, we release the SILDA, the dual-launch black structure that you can see. And finally, the release of BSat 4B. The launcher completes its mission with the start of the passivation, and from now on, the teams from the Spacecraft Mission Control Center take over and perform all the maneuver up to the final destination of the spacecraft.
And of course, Galaxy 30 and BSat 4B will be travelling to their final orbit in space, which is in geostationary orbit. But MEV2 has got a slightly different job, hasn't it?
Yes, MEV2 is really a different vehicle because instead of going to a predefined location in the geostationary orbit, it will dock to another satellite and will perform all the maneuvers that are required to maintain this satellite in position. And so it extends the lifetime of this customer.
It's really incredible and very, very exciting technology. This is the second time we've done it.
Exactly, yes.
Yeah, so it's really, really wonderful. So the computers on the ground will have now given the launch time to the computers on board. So prior to that, the launcher didn't know what time it was actually lifting off. And if you look at the top of the vehicle, you can see, we call them the cryogenic arms, those structures clamping onto the top of the vehicle, and it's pumping cryogenic propellant in. That's liquid hydrogen and liquid oxygen stored at very, very cold temperatures.
Yes, because we need to get them liquid, and so the temperature for the liquid hydrogen is minus 253 degrees, and for liquid oxygen, minus 183 degrees. And they are so cold that they evaporate, and we have to topping up continuously up to the final moment. And we disconnect the cryotechnic arms 6 seconds before H0.
So you'll see that happening just before launch. Another thing to watch out for is the fact that we switch the engines on the main stage, the Vulcan engine,
attention pour moins 1 minute.
7 seconds before the boosters.
Top, à 0 moins 1 minute.
We are 1 minute to launch. We're live at the Arianespace Center for the launch of Galaxy 30 and MEV2 for Intelsat, and BSat 4B for BSat, Maxar, and everybody in Japan. Our very best wishes to all the teams now as we sit back and watch the launch. Good luck, everybody.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. L'image Vulcain. L'image UAP. Décollage. La propulsion est nominale.
And we are off. Galaxy 30, Mission Extension Vehicle 2 and BSat 4B have started their journey. He's telling us that the trajectory is normal. And we've broken the sound barrier, Damien.
Exactly. We are now traveling faster than the speed of sound, which is equal roughly to 1,200 km per hour. And the speed will continue to increase in the coming seconds.
And look at that, Ariane 5 is blazing a trail across the night skies at the Arianespace Center, heading out over the Atlantic. Everything's going according to plan. Right now, we are using the boosters to get us away from the gravity of our Earth, aren't we? They're doing all the work.
Yes, they are doing most of the job because they provide roughly 90% of the thrust today. It is equivalent to 13 jet engines for each boosters. And their job is really to push us away from ground and to provide sufficient velocity to the launcher. And we need a lot of energy to do that. Each booster burns 2 tons of propellant per second.
That's an awful lot. And if you look at the right-hand side of the screen, what you could see there was our distance from the pad. You could see our speed or velocity and our altitude. And you'll see it again in a minute. We can see the trajectory, which is the planned trajectory. There it is on the right-hand side of the screen now. Planned trajectory, and the white cross is the actual position of our launch vehicle.
Tous les paramètres à bord sont normaux.
He's telling us that everything's going normally, and at the top of the screen there you can see our flight path. We are now
Séparation des étages d'accélération à poudre.
losing the boosters. They have done their job, they've burnt their propellant, we don't need them anymore. The lighter we are, the faster we go. And if you look at the front, the top of the vehicle, that section containing the satellites, we call it the fairing. What's its job?
Its job is to protect the satellites from the outer world. First, at liftoff, because the liftoff generates a lot of noise, so it protects the satellite from this noise.
Tous les paramètres à
And
bord sont
during the
normaux.
atmospheric flight, it protects the satellite from the friction with the atmosphere, which we call the aerothermal flux.
If you look at our altitude, you can see we're 100 kilometers above our planet. That means we've crossed the border with space, often known as the Kármán line. Getting closer now to being able to eject our fairing. That's what it looks like, because we don't need it anymore, Damien. We're in space.
Exactly. The effect of the atmosphere is now very low.
So we don't have enough thickness in the atmosphere for friction to bother us. And we can see our satellites for the first time. At the front there, you can see Galaxy 30 and MEV2. And then there's a black structure, that's called the Silda, and inside that is BSat 4B. You can't see it right now, but hopefully we'll see that later. You're getting information in your ear, aren't you? The range operations manager's hearing it, and you're hearing it too.
Yes, I have a direct link with people located near the launch pad. They are located in Galio, a few kilometers away, and they receive directly the telemetry from the launcher and gave all the confirmation and all the status, and the range manager receives exactly the same information.
And at the Space Center, the range operations manager is responsible for calling that out to everybody. Our flight path takes us out across the Atlantic. We're traveling along the equator. We have a number of tracking stations along that flight path, and they pick up the signal. You can see our flight path there. They pick up the signal from the launcher as it flies over. Is that right?
Exactly, and we have a network of stations which are located all over the flight path. The first one is located in Galio, which is a few kilometers away from the launch pad. It will cover all the beginning of the flight up to the main stage flight. We have then Natal, located in Brazil, which will cover part of the main stage flight. And then we have the next station, which is called Ascension, which is located in the South Atlantic. And we have in a gap, what we call a telemetry gap between Natal and Ascension. It means that we have a loss in the visibility, but this is completely nominal because we foresee it, and we do not lose the data because we record them in the onboard memory, and we download them when we are back in visibility. The next station is Libreville, and we have exactly the same phenomenon between Libreville and Ascension, where we have a telemetry gap, which is exactly nominal. And at the end, we will be in direct visibility of Malindi, which is located in Kenya. And Malindi will allow us to follow the end of the flight, and in particular, the ballistic phase, where we will have the separation of all our passengers.
Thanks very much indeed for talking us through that, Damien. So that's the last station you can see there on the film, Malindi in Kenya. And the guys and girls there will be tracking the separations. Joining us now in the studio is Raphael Chevrier. Raphael is a business developer at Arianespace. Thanks very much indeed for being with us, Raphael. That means part of your job is very much looking to the future, thinking about future technologies and innovation.
Yeah, absolutely. And actually, if you think about it, like only 6 decades ago, we've been launching the first spacecraft in space. And in the meantime, we've been sending humans on the moon, spacecraft on Mars, on asteroids and beyond. And so a lot has happened in 6 decades. And today, we are launching satellites for telecommunication, internet, navigation, Earth observation. So you can see that space is really part of our daily lives. And that's very, evolving a lot.
Absolutely, and the people who are making that happen are there right now. We're looking at various important people there in the Guyana Space Center. Who are they and what are they doing?
Here we can see the people from ESA, the European Space Agency, and these people are currently monitoring the overall status of the launcher to check that it was inside the qualified domain. So here we see the head of the ESA office in Kourou.
All these teams very important, getting the scheduled moment here for the acquisition of the signal, picking up the signal at the tracking station in Natal, in Brazil, one of those tracking stations that you mentioned to us back there. And there we have the confirmation there from the range operations manager that we've picked up that signal. Raphael, and he's telling us, just a translation for everybody, that everything on board is going according to plan. Raphael, given that the launcher operates remotely, why is it important for us to have the tracking stations?
Well, it's very important for, I would say, two main reasons. The first one is safety. It's always safety first when it comes to launch satellites in space. So you really need to make sure that you have visibility of over the whole launch sequence, and especially in dynamic phase of the launcher. And so, you really need to know how to react if something happens. And then the second is you collect data, and then you can know more about your launcher for the next launch.
And we have separation there of the main stage and ignition of the upper stage. This is very much now the next phase of our journey. And the range operations manager has confirmed that we have the upper stage engine switched on. The upper stage is a very important piece of kit. Its job is to deliver our satellites into space. Damien, whereabouts has it got to take them?
Exactly. It will deliver our customers to an orbit that we call a geotransfer orbit. The geotransfer orbit is particular in the sense that it is elliptical, so it's like a shape of an egg. You have the short part, which we call the perigee, which is located close to the Earth, if we have an ellipse. And the highest altitude point, which we call the apogee, is the apogee of the geo orbit, which is 35,786 kilometers. And this orbit is really important for our customers.
Yeah, I mean, GTO orbit, geo orbit has been used intensively to launch telecommunication satellites mainly. And it's very also important because the satellite stays on a fixed point. Is like following the rotation of the Earth. It's like when you are like holding your child's hand on a roundabout, then you're staying at the same position with respect to your child when your child is turning around. So it's very important that you can deliver services daily, like 20 hours a day.
And right now we're looking at a replay. This was 10 minutes and 28 seconds ago. We lifted off from the pad at 7:04 French Guiana time. That's what it looked like. It was a really beautiful launch. It was incredibly impressive. I always feel a bit sorry for these guys because they have to watch the launches on screens, whether you're in mission control or whether you're in launch control. Have you seen launches in real life?
I had this opportunity once, so it was really impressive. This is a moment that I will always remember because you are impressed first by the power, because you really feel the power of the launch. And then you see the light, which is really impressive, and the noise generated by the launcher. So even if you know how it will work, nevertheless, you are impressed when you leave it alive. And this is really something that you will remember for years. And I guess it was the same also for you, Raphael.
Yeah, it was pretty much the same. Like I remember the bright light and the sound coming from the ground. That was very impressive. And I also remember that I was really hesitating between like taking pictures with my phone or leaving the moment. And I quickly put my phone back to my pocket and lived the moment because like the images are like just breathless, really.
Yeah, it's a really exciting thing, and you actually feel the vibrations as well, which is quite impressive, isn't it? And of course, Ariane 5 is the biggest of the family of launches here. She's incredibly big, and Raphael, today she's more efficient than ever. Just very, very briefly, tell us why.
Yeah, it gained over the years, 2016, 300 kilograms of performance. So DNA is part of innovation is part of our DNA, and we continuously improve the performance for the customer's benefit.
Absolutely. Let's go and watch a film now and see what those improvements involved.
Well, for the Ariane 5 performance increase, we've introduced the so-called Performance Increase Competitiveness program, which is mainly addressing two axes. The first one is elongating the tanks to put more propellant inside. This is in the ESC part. But secondly, we were elongating the equipment bay, the VE-BH, to enable much more payload inside the Ariane, and introducing also a more innovative membrane, which will also be used in the future in the Ariane 6. Soon as we finished PIC, we had to start with PIC because the market was demanding much more performance. It was basically increasing the space below the CILDA, the so-called double-seat adapter, increasing the space in the cone, and last but not least, lowering the apogee to also serve the sub-GTO. With all these measures, we gained additional 500 kilograms of performance. The philosophy for Ariane 6 is a totally different one to Ariane 5. Of course, we build up on our heritage of the Ariane family, but for Ariane 6, we use the modular design from scratch to make it versatile and scalable for all customers and the fast-evolving market. Among all the different things we have at stock, I would like to mention Icarus, our innovative carbon Ariane upper stage, fully made for performance jumps into orbits which we have not visited yet. For example, the cis lunar orbit. And these are topics which we have in our pipeline, thanks to all of our good engineers, our excellent teams, which make it happen. Thank you to all of them.
Well, now, during that film, we picked up the signal. We've heard from the range operations manager. They're telling us that everything's going normally on board. We will have picked up the signal
from Ascension again.
From the tracking station in Ascension Island, which is in the middle of the Atlantic Ocean. Damien, how does... Well, I was going to ask you, how does Ariane know about where she's going? But we're going to watch a film about the vehicle equipment bay.
Embedded software. What is the biggest challenge for developers? What exactly is embedded software? It's the brain of the launcher. It is set for each flight and allows the rocket to navigate independently once the engines have been started. All the phases of the mission are programmed within it. It controls the smooth progress of the flight and is ready for any events that may occur. It reacts accordingly and adjusts the launcher's actions in real time. It is placed in the equipment bay, right at the top of the launcher. It usually takes between 5 and 10 years and a team of 100 people to develop it. Just to recap, the embedded software is able to send a 750-ton rocket into space to analyze and respond to all eventualities, and all this with complete autonomy. Not bad, is it? But that's not all. Once in space, the launcher and its software are no longer protected by the Earth's magnetic field. Without adequate protection, solar radiation would damage them. So the engineers have designed dedicated electronic circuits to withstand this extremely hostile environment. And that's how you fly a rocket into space, through solar radiation at 8,000 kilometers per hour.
Well, when you see such an extraordinary advanced technology. It's no wonder that people from all over the world watch our launches. And we've been asking you to write in on social media. Everything's going well. To write in and ask us your questions. And the guys here have done a little triage and picked out a few questions. I'm going to start with you, Damien. A lot of people have asked us about the new rocket which is being built, Ariane 6, and a lot of people are really keen to know, will she be able to carry people?
Well, the first step, of course, is reliability, because if you want to carry people, you need a very reliable launcher. And reliability has always been of utmost importance for Ariane family of launchers. It was the case, of course, for Ariane 4, and then in Ariane 5 again. For Ariane 6, reliability will be, of course, a key requirement. And I would like also to recall that for Ariane 5, at the beginning of the project, we have a project named Hermes, for which we were supposed to carry people. And this is why we have a really reliable, redundant launchers in terms of reliability.
Yeah, and Europe also developed pressurized modules. So I agree with you, Damien, that Europe has everything needed to do that. The experience, the technology, and as a matter of fact, this market is getting stronger and stronger. I mean, right now, astronauts are going to the International Space Stations. Tomorrow they will go to the moon very often. And we know that our European astronauts take off from Russian launchers, tomorrow maybe, probably from American launchers, but just imagine what the emotion it would be to see a European astronaut taking off from Kourou. It would be just amazing.
It would be fantastic, wouldn't it? It would be really wonderful. Just a quick note to say that we've picked up the signal at the tracking station, the Libreville tracking station, which is on the west coast of Africa. Now, our first passengers to be released are Galaxy 30 and MEV2 for Intelsat.
Le pilotage est calme, tous les paramètres à bord sont normaux.
It's a pleasure to be with you today to celebrate the launch of our newest satellite, Galaxy 30. I want to start by thanking two long-standing partners for their ongoing commitment to Intelsat's success. Arianespace, with our 62nd launch together today, and Northrop Grumman, which has manufactured 11 Intelsat satellites. It's an especially exciting launch day for us at Intelsat because Galaxy 30 shares a ride to space with Northrop Grumman's second mission extension vehicle. Our Intelsat 1002 satellite will be the very first customer of MEV2 services next year. We were proud to partner with Northrop Grumman on their historic MEV GEO orbit servicing mission earlier this year, and we look forward to pioneering this second mission with them. Thank you to the Intelsat planning, engineering, and operations team who have been passionately involved in the Galaxy 30 and MEV2 programs. There's also a deeper purpose and significance to these launches. Every new Intelsat satellite in space means that we're able to connect even more communities, businesses, and governments, and in turn, to empower even more people with life-changing connectivity and communication services. Galaxy 30 is Intelsat's first satellite to utilize 4 frequency bands, with C, Ka, Ku, and L-band services. It will play a key role as part of our C-band cable distribution neighborhood in the United States. It will also serve network, enterprise, and government customers with its extensive coverage of North America, including a hosted payload for the Federal Aviation Administration in conjunction with our partner Leidos. Thank you, enjoy today's launch, and go Galaxy 30 and MEV2.
Every satellite launch is important for us. Our satellites are our assets in the sky. This particular launch replaces one of our very key video neighborhoods for our media customers over North America.
My name is Pascal Fromont. I'm the Director for Product Management of our Media Business Unit here at Intelsat.
Galaxy 30 will be there to enable this richer, higher quality content to reach the viewers and to keep entertainment, news, and sports reaching homes at its best quality in a way that is hyper reliable, always on air, ready to be consumed.
This launch is not your typical launch. Since the launch of our first satellite back in April 1965, so that's 55 years ago, Intelsat has launched 150 satellites. This is the 151st satellite that we launched. But it's actually the very first satellite that has 4 different frequency bands. It will enable a slew of new applications. It really takes a village to design, build, test, launch, and then operate a communication satellites.
It's really amazing how we pull together these different organizations with a common goal. We all really enjoy this kind of work. We get on the console at launch minus 10 hours. And once they ignite those solid rocket motors, it's 100% commitment. So you go through this wave of anticipation, worry, calm, and then relief. And then we open the champagne at the end when it's successful here in French Guiana.
We're here with a mission. We're here to connect people around the world. It's really a very inspiring business to work in.
And Galaxy 30 and MEV2 are the 22nd and 23rd satellites that Arianespace is orbiting for Intelsat. Pretty impressive. We are coming up to the acquisition time for the tracking station in Malindi, so wait.
Acquisition de la télémesure par la station de Malindi au Kenya.
Okay, we have that tracking station. So they're now following our launcher. Back to our questions from our viewers. Raphael, Lucy has asked us, is Europe planning any missions to the moon or Mars?
Well, I will start with Mars because it's a very good timing to ask these questions, because 2 weeks ago, as you probably know, there is this Perseverance spacecraft that developed by NASA and took off from the US. Is going to Mars, it's going to the surface, it's going to grab samples there. And 6 years after that, in 2026, there is another spacecraft developed by Europe, which will take off, go there, grab the samples in orbit, in the Mars orbit, and bring it back to Earth, and it's going to be in 10 years from now. So this is a good example of long-term cooperation with in space.
Yeah, no, it is, and it's incredibly exciting, and these are really inspirational and wonderful missions, aren't they? So we have another question, actually, the same one for you, Raphael, because Juanita is quite a related question, has asked us, are you working with other space agencies like NASA, for example?
Oh, absolutely. I mean, we are working, like Europe is working with almost all national space agencies in the world. And, well, talking about NASA, just to give you an example, next year, Ariane 5 will launch a very important project. This is the James Webb Space Telescope. A lot of people are waiting for this to be in space. It's going to go at 1.5 million kilometers from here. And it's going to observe the deep space, for example, stars or galaxies that have been formed right after the Big Bang. So it's a very major project, and there are many, many more projects that are made in cooperation.
That's incredible. This is going to be giving us even more remarkable information than James Webb. So that's very, very, very exciting.
And we have a lot of pressure on our shoulder on this.
Sorry, I meant even more information than Hubble. I meant to say, yes, of course. So this is the scheduled upper stage cut-off time for our engine of our upper stage. So we are on altitude and at the right speed, and we are now going into the ballistic phase, Damien?
Yes, we have a nominal confirmation for the shutdown of the upper stage engine.
So that's good to know. Ballistic phase means that we're traveling without propulsion. We're cruising without the engine, and we're entering into the next phase now. Just very briefly, let's go back to some of our questions, because somebody wanted to ask, Wesley actually has asked, Damien, this is one for you. What advice would you give to young people wanting to get into the space business?
Well, first, you don't have to be part of the space business or being part of our domains today to join the space community. Because if you are working as a computer scientist, as a manufacturing engineer, electrical engineer, orbital mechanics engineer, structural engineer, whatever, we need all types of engineers and technicians to work. And we have several places where people can join the space community. We have industries like Ariane Group, we have Arianespace for launch service provider, and we have also the space agencies, CNES for the French space agency, ESA, and we have also International Space Agency where we can work if we need.
Yeah, and space is not just about engineers. There are lots of jobs in space. Commercial, communication, lawyers, and etc. But one thing is certain is that when you join the space sector, you become very quickly part of the family and very quickly passionate about space.
And this is indeed one big family. We can see here at the Guyana Space Center. Who are we looking at, Damien? Are these the Galaxy 30 teams?
Yes, we are looking at the operational team who have worked very hard in the latest day to complete the preparation of their spacecraft. And they are now waiting with eagerness the separation of their spacecraft, which will be like a birth for them because the spacecraft will be ready and will complete its journey on its own.
And this is what it looks like up there, that berth that you talked about. This is the scheduled separation for Galaxy 30.
Séparation Galaxy 30.
And we have confirmation there from the Range Operations Manager. Galaxy 30 has now started its new life in space. It's making its way away from the mothership. There you have it, successful separation. Good news for our customers, right?
Very good news. A very good step for the customers.
And the space ballet continues, of course.
This was an important milestone, and the maneuvers will go on in order to prepare the separation of the next spacecraft.
So our next satellite to be released is MEV2, and it was also supplied by Northrop Grumman for space logistics. Let's find out a little bit more.
Hi, I'm Joe Anderson, Senior Director at Northrop Grumman and Vice President of Space Logistics LLC, a Northrop Grumman company. Earlier this year, our first mission extension vehicle, MEV1, made history when it docked with a satellite running low on fuel, the Intelsat 901. Now IS 901 is back in service thanks to our innovative technology that gives satellites a new lease on life. Our low-risk docking system keeps the customer operational and extends the lives of useful satellites. Once our services are no longer needed by the customer, the MEV is able to undock with the client satellite and continue on to our next customer. Today, we are ready for the launch of our second MEV, which will perform its first docking with another Intelsat satellite, the IS-1002. On behalf of Northrop Grumman and Space Logistics, I want to thank Intelsat and Arianespace for being trusted partners on this innovative mission. Finally, we have a short animation that shows the MEV-2 mission in more detail. Go Ariane and go MEV-2!